Good afternoon, students, and welcome to your second video lesson for our college algebra class. Today is actually going to be fairly short, I think, unless we get into some examples that really kind of take our attention and take a good bit of time to explain. I didn't receive any questions or any emails from last class, so that tells me that you either didn't watch it or you understood everything that was said and you are good to move on with no questions asked. So I hope it's that one, because if not, then snooze you lose. You're running out of time before your first test, which is coming up very soon. I want to take the time to remind you that the link to our tentative course schedule is still posted in Wolfden. It is also posted in the Google Classroom for you to view, and so that you can just follow along. What you will see is for today's date, which is the 23rd, that we'll be doing sections 3.3 and 3.4. Next class, we will be continuing that and adding a little more to it. And then to start next week, we will actually have a test review time. As of right now, I'm trying to plan something where we could meet face-to-face as an option. And if you have any questions or you want to log on, then you and I can see each other face-to-face and ask those questions. But if not, then you would not have to, you wouldn't have to do anything except log in and check in with me during that time frame. I will let you know more details about that as we get closer to that date. I will let you know what technology we are using for that as well. It will most likely be Zoom, just because I'm finding that that is just an easy application tool to use, and we can see each other, but we can also view documents at the same time, which is really helpful for math. But stay tuned for that. Check your emails, check your Remind apps for any messages from me, and we will go from there. All right, to get started, we will be in, again, Chapter 3. We're looking at 2 sections today. We'll continue and finish up those 2 sections on Thursday. I wanted to just kind of split it, and that way you have some time to process. Today's is pretty easy. It's one it's one item, one's theorem, as you would say, to learn, and I find that it's a fairly easy one. It's fairly easy to calculate. It's just division. There's really nothing else much to it, but it's important for us to learn the title of that theorem and what it actually means. You'll notice that these sections are still dealing with zeros of polynomial functions. I will remind you that a polynomial function is a function whose largest power is at least a 2. Typically, we'll call those quadratic functions, and everything with a power of 3 and higher we would refer to as a higher power polynomial. So everything that we're looking at today is going to have at least a power of 2. Most likely it will be a power of 3, a cubic power, or something x to the 4th, or something x to the 5th, the 6th, on and on and on. Okay, and so here we go. This is just a review from last class. Identify the parent function, what's the end behavior, the maximum number of zeros that each of these functions could have, and the number of turning points. And then I actually want you to calculate what the actual solutions are. And if you got some graph paper, or if not, just sketch a rough draft of this graph, which you should be able to do since you know the end behavior, you'll find the solutions, and you'll know the turning points. So based on those 3 key pieces of information and the parent function, you'll have a really good idea of how to sketch a rough graph. So pause the video and see what you come up with. I am not going to do the first one because you have got your graphing calculators. You can check your answers there. I would encourage you to do both just as a review to get warmed up for today's lesson. I'm just going to work through the second one, f of x equals x cubed minus 8x squared, mostly because that's one that we're not necessarily seeing as much of. That top one we've seen multiple functions like that over and over again. So if you don't know how to do that one, use your graphing calculator as a resource. Use the details from the second one that I give you to help you with the first one. So pause the video and see if you can find out this information. And this will be a good indicator of if you actually learned what you needed to from last class. So pause video. Okay, so what you'll see, there's a lot going on up here, obviously. First thing that I did is I color coordinated a bunch of things for you. So the first thing in the directions was to identify the parent function from f of x equals x cubed minus 8x squared. Well, this is a cubic function, so its parent function would be x cubed in red, and you can see that right here. And I even did a little rough sketch graph of what the parent function looks like, just to give me an idea of how I'm starting with the end behavior, to give me a visual of what this graph started out looking like, and then I'm going to transform it from there. Okay. The next thing I was asked to find is the end behavior. Well, we talked about the end behavior rules last time, and so end behavior is always dependent on the highest power. So is the highest power even or odd? And is the leading coefficient positive or negative? And for this function, I have a positive leading coefficient and an odd power, and so the left hand is going to be going down or approaching negative infinity, and the right hand is going up or approaching positive infinity. Sorry about that, y'all. I had to pause the video. I had some dogs going crazy and making a lot of sounds and destroying my house. So I don't remember what I said last, but I think I was talking about end behavior, which is in the blue on the right side of your screen. The next thing that we were asked to find is the number of zeros, or the number of the maximum number of zeros. And again, that is found simply by looking at the highest power of your polynomial. And this one, it is a 3, and so the maximum number of solutions I will have is 3. Now remember that those could be rational or real, or they might be imaginary. That is something that we will address and look at the remainder of this chapter. Number of turning points is the highest power minus 1. Remember, turning points is just where your graph literally turns direction. At a certain point, it's going to turn direction. And right now, all I want is how many there are and just a rough sketch of where they may land. I'm not asking you to calculate their specific location. I just want to know how many there are in a rough sketch of them. The last thing we were asked to find before we graph this is the actual zeros. Now, this is a cubic function, and so you cannot do it the quadratic formula because it is not quadratic. So the only option that we have right now is to factor it. X cubed minus 8x squared, when we start factoring, the first thing that we notice immediately with this one is that it only has 2 terms. That constant, or that c term, is not written, it's not present. It is just 0. So when we see something like this, when we have a higher power polynomial with 2 terms, one of the things we may want to start out trying is looking at those 2 terms and seeing what they have in common. Do they have a greatest common factor? X cubed minus 8x squared. And just by reading that, saying it out loud, x cubed, 8x squared, as I'm reading that out loud and I'm listening to what I'm saying, I'm hearing that both of those terms have multiple x's. The most that they have in common is an x squared, which means I can take out or factor out the x squared. And that would leave me x minus 8. Now that that is factored, we can set each piece equal to 0. So x squared equals 0 and x minus 8 equals 0. And by solving that, it's a little weird, but we would take the square root of both sides to solve this first piece, and we would get 2 solutions of x equals plus or minus 0. Well, 0 does not have a positive value or a negative value, so this solution is just x equals 0. But The good thing about knowing that when you take the square root, it's plus or minus, that automatically indicates two solutions. And so 0 must count twice, aka it has a multiplicity of 2. And so when we graph this function, okay, it is going to intersect or hit the x-axis at 0, but it's going to bounce off of it. It's not going to cross through it because it has a multiplicity of 2. It has an even multiplicity. Okay? And then our other solution is x equals 8. And so the only thing I have left to do is go do a rough sketch of this graph. And so first thing I'm going to do is I'm going to plot my solutions, x equals 0 and x equals 8. 1, 2, 3, 4, 5, 6, 7, 8. And I know that it's got this type of shape because its parent function is x cubed. Okay? Its parent function is x cubed. And I know that my end behavior is the left leg or the left hand down and the right hand up. Okay? The other thing I know is that there's a multiplicity of 2 here. And that should be really easy to see because if I completely forget about the multiplicity thing, and I just draw right through my points, when I get over here, and I'm trying to hit the x-axis, there's no way that I can get back up to the right hand up without following some type of multiplicity rule. That's what I was talking about last class when I said there's kind of a checks and balance there when you're graphing. As long as you know how much of a multiplicity you have and your turning points, once you graph those solutions and in behavior, it forces you to take some kind of rough shape of your graph. Okay? You just have to still decide where it is, and again, you have graphing calculators. Okay? So x equals 0 has a multiplicity of 2. I'm going to hit 0, but then I'm going to bounce off of it. And then the only thing I can do to make sure I maintain the end behavior of right hand up is to decrease and curve back up to x equals 8. And there is the full shape of my graph. Now again, we don't know the exact location of the turning point. We don't know how far that goes down or how shallow it is. And I'm not asking you for that. All I'm asking for is that there are 2 turning points. Okay? And we can see that in the picture. Let's see. We can see that in the picture right here. There's 1 point. Notice how I go from increasing to decreasing. That counts as a turning point. And then somewhere down in here, we don't really know where, there is a second turning point where I change direction from decreasing to increasing. Okay. If you need to pause and take some more notes on that, please do so. If you need to pause and take care of doing the second one, also do that as well. Otherwise, we are going to move on. So now that we have reviewed finding the number of solutions by factoring, but we also know we could do quadratic if it is a quadratic function. Okay. We need to add a little more to that. Okay. We've also reviewed how to determine how many solutions or the maximum number of solutions that a function can have and turning points, yada yada. But we may not always know how to find them. What if we can't factor the polynomial? So what we just did, what if x cubed minus 8x squared was not factorable? Well, we can't use quadratic formula, and then if it's not factorable, then we need an option C. Okay? We need a third option to choose from to help us find those solutions. Okay. And so that leads us to half of this lesson today and our learning target, which is I can determine the number of possible roots or solutions or zeros that a polynomial function may have. Okay. So what we are learning today is if the graph is not quadratic, I can't use the quadratic formula, so that option A is out. If it is not factorable, option B is gone. Here is a third choice for you. If I can't factor, or for a lot of you, if I can't remember how to factor, I need another way of getting my answers. Or I need another way of getting my solutions. this today is the start of how to get there. And it is something called the rational root theorem. Now, the rational root theorem simply says this, and I don't have it written out in front of you because it speaks to itself. You'll see right here in the wording, list of possible rational solutions without factoring. Okay, the rational root theorem, you may want to write this off in your notes. The rational root theorem tells you here is a list of all the possible solutions that this function can have. So right here, f of x equals 9x to the 7th plus 8x to the 6th plus 7x to the 5th plus 6x to the 4th. Okay. I don't think anybody in the room wants to factor that. If you do, you go ahead and you try that. I'm not going to. But when we see higher power polynomials like this, we can't use a quadratic formula, and most of us would not know where to begin as far as trying to factor this. And so our third option begins with the rational root theorem, which says, all right, so we know that there is a total of 7 solutions. Okay? But remember, those solutions could be real or rational, hence the name of this theorem, or they could be imaginary. The rational root theorem is going to give us a list of possible rational solutions for us to choose from. That is all that we are doing today. Okay? Let me repeat that. All that we are doing today is focusing on getting a list of possible rational solutions. Next class we will focus on, all right, we have a list. How do we figure out which ones are possible and which ones are the actual answers? Okay? So we're splitting that. Okay? So today should be fairly easy for you, but you've got to know today in order to be successful on Thursday. Okay? So take a few moments in your notes. The rational root theorem, you should have already written down just very briefly. The rational root theorem gives you a list of possible rational roots or rational solutions. Okay? But here's how you actually calculate the possible rational roots or the possible rational zeros, the possible rational solutions. And like I said at the very beginning, it's actually a very simple calculation. It's just division. All that the rational root theorem says as far as calculating is this. You're going to create this giant fraction. And in the numerator of that fraction, you are going to list every factor of your constant term in your function. Every factor, including the positive and the negative factors of that constant term. Okay? Divided by, so in the denominator, you are going to list all of the factors, positive and negative, all the factors of your leading coefficient. So you're looking at your smallest term, and then you're looking at your largest term. Smallest term meaning the term without an exponent, or with the, without an exponent, because that would be the constant, divided by the factors of your leading terms factors. Okay? So, for example, we've got this function sitting right here. What is the constant term in this function? Okay? And hopefully you are all kind of either sitting there going, huh? Or you're saying there isn't one. And both of those will be kind of correct. There isn't a constant term in this function. The smallest term that we have is 6x to the 4th. There's nothing else beyond that. The constant term is just a number, and we don't have just a number. So it would act, or for this function, our constant term would be 0. So what are factors of 0? What times what gives you 0? Okay? And we would say 0 times 0. Okay? And if you want to be super technical just to help you out for future problems, you can put plus or minus 0 because we want to make sure we include all the positive factors and the negative factors. Okay? Divided by, now I need all the factors of your leading coefficient. Well, your leading coefficient is the term with the largest power. So again, take a look at this given function. What is the largest term? meaning what is the term with the largest power. It's written in standard form, so we are grateful and we are thankful that the largest term is sitting at the very front. And so what is the leading coefficient of that largest term? It is a 9. So in the denominator, I need factors of 9. I need all the positive and negative factors of 9. And so we can say positive 1 and negative 9. We could say negative 1 and positive 9. Those are both factors of 9. I'm sorry, I said that wrong. We can say positive 1 times positive 9 are factors, or negative 1 times negative 9 are factors. That was my apologies. Okay. What other factors do we have of 9? Positive 3 times positive 3. You don't have to write it twice. Okay. Or negative 3 times negative 3. Okay. And so that is kind of our first step. Now our next step is to write all of those out individually. So we need to have a list of possible solutions from that fraction. And so all we're going to do is we're going to take the numerator. Each numerator must go to the denominator. Okay? So 0 divided by 1, okay, or plus or minus 0 divided by plus or minus 1, plus or minus 0 divided by plus or minus 3, and plus or minus 0 divided by plus or minus 9. We got to split that so that we can get that full list of possible solutions. Okay, so here we go. Plus or minus 0, that numerator, that first numerator piece, divided by the first denominator piece of plus or minus 1. Plus or minus 0 divided by plus or minus 3. And plus or minus 0 divided by plus or minus 9. And you'll notice that I'm writing all of those factors with the plus or minus included. Please acknowledge that that is representing two factors, two number values there. If that confuses you, then you can write them all out separate. You can write out 0 divided by 1, comma, 0 divided by negative 1, comma, 0 divided by 3, comma, 0 divided by negative 3, comma, 0 divided by 9, comma, 0 divided by negative 9. You can do that if you want. When we start getting solutions where there's 30 possible solutions, writing it like this is a more condensed way of writing it, because all of your answers are going to end up being plus or minus anyways. So, for example, even if I had split how I wrote this term right here, if I had split it to say 0 divided by 1 and 0 divided by negative 1, my answer is still going to be plus or minus 0 in a weird way. Okay, 0 divided by plus or minus 1 simplified is still 0. 0 divided by positive 3 is 0, and 0 divided by negative 3 is also 0. And plus or minus 0 divided by plus or minus 9 is also 0. Well, we don't need to have that written 3 times. The only possible real solution or rational solution for this function is 0. That does not mean that it is the actual solution. That just means it is the only possible rational solution. So at most, we would have one real solution at 0, and then the other 6 would be imaginary. Or 0 is not even an actual solution, and all 7 of our solutions would be imaginary. For today's lesson, that's as far as we're going to go. Next time, on Thursday's class, we will actually find a way to test and see if 0 is an actual rational root or an actual solution or not. But for today, all we are doing is this process. Now, all we're doing is finding out the possibilities. Next class, we will take the possibilities and figure out which ones of those are the actual answers. And so here we go. We've got some extra practice here. And again, I'm going to do all 4 of these because it shouldn't take us super long to get through these, because we're only finding the list of possibilities. We're not finding the actual solutions. Okay? So for the first one, okay, I want the list of possible rational solutions. For the record, my directions are right up there. I'm just moving my screen around so that I've got plenty of space for us to work with. Okay, so I want to find all the possible solutions for that first function. And so I need a list of factors of the constant in the numerator divided by all the factors of the leading coefficient. Okay? So first of all, what is the constant in this first function in number 1? Okay? And that would be a -1. So I need factors of -1 divided by factors of the leading coefficient. Well, the leading coefficient is the number sitting in front of the largest term, okay, which would be right here. So I need factors of +3. Okay? And so from there, here we go. What are factors of -1? Okay? Well, we could say that would be a +1 and a -1, or -1 and +1. Again, you can either write them out one by one, or you can write them condensed like I am. I prefer this method better, but you do what you prefer. Okay? Divided by, I need factors of +3. So I could have factors of +1 and +3 that multiply to give me 3. Or I could have -1 times -3. Okay? And then there are no other factors of 3. And so now my next step is to write each of those out individually. And so here we go. I'm going to take each numerator needs to go to each denominator. So plus or minus 1 divided by plus or minus 1. Comma. Plus or minus 1 divided by plus or minus 3. And then the only thing we have left to do to finish this problem out is to simplify that. Now, with all of these being plus or minus, you don't have to keep writing them in the top and the bottom, or in the numerator and the denominator. You can just write plus or minus. Okay? So plus or minus, and then what is 1 divided by 1 simplified? 1. Okay? And then plus or minus 1 divided by 3 is 1/3. And so there are our possible rational roots or rational solutions for that function. Now, how many total solutions can I have for this one? I have a total of 2 solutions, and those could be real or those could be imaginary. And the reason why I know that is because the highest power is a 2 up top, and so that means I can only have 2 total solutions. So both solutions could be real / rational. Both solutions could be imaginary. One could be real and the other one could be imaginary. We don't know right now. Okay? All we do know is that those 4, notice that that's 4 possible solutions: +1, -1, +1/3, -1/3. All 4 of those are possibilities for being solutions. And so what we would want to do is we would want to test those and figure out which of those, either 1, 2, or none of them, work as solutions for this function. We're not testing today. We will do that next class. Okay? But you got to understand where the possibilities come from so that you have a list to test next class. For that second one, for number 2, I'm going to pick up the pace a little bit. I need to find all the possible rational roots for x to the 6th minus 64. Now again, it's not quadratic, so I can't use quadratic formula. I don't think many of us in the room want to try and factor that either. And so our third option is to get a list of possibilities. Get the list of possible solutions, and that will come from factors of my constant, which is -64, divided by factors of my leading coefficient, which is 1. Okay. And so that is where I will start. I need factors of negative 64. So positive 1, negative 64, or negative 1, positive 64. I've got a 2, a positive 2, and a negative 32, okay, or negative 2, positive 32. Okay. 3 is not a factor, okay, but 4 would be. Okay. So I could do positive 4. I'm running out of room here. Okay. Positive 4, negative 16, or negative 4, positive 16. 5 doesn't work, 6 doesn't work, 7 doesn't, 8, okay, 8 would work, positive 8 times negative 8, or negative 8 times positive 8. Okay. I'm going to rewrite all of those because it's gotten really cloudy there, so I should have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus plus or minus 32, and plus or minus 64, just so I can keep it as clean as possible. Okay, and then divide that by all of my factors of the leading coefficient, which the leading coefficient is just 1. So positive 1 and negative 1 are my factors. Okay. And then the same thing that we've been doing, I need to write each of those solutions out individually so I get my full list. Every numerator needs to go to every denominator. And so I've got plus or minus 1 divided by plus or minus 1. Okay. That's the only denominator. Okay. That's the only denominator, so this one's done. Throw it out. I can move on to the next numerator. Plus or minus 2 over plus or minus 1. There's nothing else for the 2 or the plus or minus 2 to go to, so I can throw it out. I've already written it down. Plus or minus 4 over 1. Plus or minus 8 over 1. Plus or minus 16 over 1. Plus or minus 32 over 1. And plus or minus 64 over 1. Now keep in mind, if your leading coefficient, so this number right here, if your leading coefficient was 2, you would have to write out all of those solutions and all of the solutions divided by plus or minus 2 as well. So this has the potential to get very complicated. There's a lot of possibilities that could show up here. When I simplify my answers, which these are easy, everything's divided by 1, so my solutions are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32, plus or minus 64. But I need you to acknowledge that that is 2, 4, 6, 8, 10, 12, that is 14 possible solutions, or possible rational roots. On your test, I'm going to ask you some questions like, please list all the possible rational roots for this function. And this is exactly what I would expect your final answer to look like. The only difference would be if you wanted to write them all completely separate. So if you wanted to write positive 1, comma, negative 1, comma, 2, comma, negative 2, on and on and on. Okay? But this is it. Keep in mind why we're doing this. This is your third option of finding actual solutions for a function. These are not your actual solutions boxed out at the bottom. These are the possibilities. On Thursday, if this was a problem and the direction said find the actual solutions, you would have to show me how you figured out which ones of those are the possible ones and which ones are the actual solutions. And you will not just be plug it into your graphing calculator and whoop, there's the answer. You'll have to present and give me all of that work. So it is not a free pass because your test will be online. You will have to submit to me some shown work. That it will either be done on the computer or it will be written out on notebook paper that you have to email me within a certain time. Otherwise, I'm not going to accept it. Okay? We'll talk about the specifics of your test closer to that date, but you need to be aware, you need to be following along and taking notes, and you need to be showing your work and working things out with me as you go. If I'm working them out and having to do all this work, then you should definitely have to be doing it because you're the one that's learning the content, not me. Okay? So please make sure that you are following along. Okay? I'm going to leave those second ones up there, or the third one and fourth one up there for you to practice with. I'll help you get started. So for number 3, I want the list of all the possible solutions. So I want factors of negative 21 divided by factors of the leading coefficient, which is positive 5. So what you need to do is pause this video and write out all the factors of negative 21 and all the factors of positive 5 and get your list. So pause the video and come up with your list of possible solutions or possible rational roots. And so there are all of your solutions, or all of your possible solutions for that third function up there. And you'll notice that some of these are pretty nasty. I mean, 7/5, you would never get that as a solution with factoring a lot of times. Usually they come out as something smaller, like maybe a half or 2/3 or something, not as complicated as that. But the reality is, those could be your solutions for 5x to the 4th plus 32x squared minus 21. Okay? Next class, you need to be prepared to work with fractions like positive 7/5 and negative 21/5. You're going to be multiplying and dividing with those. And now be grateful that you have calculators either on your computer or the actual calculator tool itself in front of you. But that's not a free pass. You still have to know how to operate that. You still have to know how to type those in. And I showed you that at the beginning of this course. That's something that you should have learned a long time ago as well. But if you were not paying attention, then you're kind of on your own, because I'm not sitting there in front of you telling you exactly what buttons to press. So please make sure you know how to use your calculators and have them available to you on Thursday's class, because you're definitely going to want them. Otherwise, you're going to be multiplying 21/5 with other numbers, and you're not going to appreciate doing that by hand. Okay. I'll go ahead and set the fourth one up for you. Pause the video and see if you can find the list of possible solutions for that fourth function. Here is your list of possible rational solutions or possible rational roots for your fourth function. Okay. Keep in mind, if you've got any questions along the way about specific problems that we're doing or just content in general, it'd be a good thing to pause the video and send me a reminder or an email immediately about that content, or write it down in your notes, put question marks or stars beside it, and then you can send me an email or a reminder later about that as well. And so one of the things that you kept seeing on in the rational root theorem is we have to account for the positive and negative solutions, or possible solutions that are out there. That's why as we're listing out these solutions, we're doing plus or minus 1, plus or minus 1/2, because it could be the positive version or the negative version of that solution. Well, those are for the real solutions or the rational solutions. What happens when we start dealing with the imaginary ones? So the ones that exist, but we can't necessarily see them on a graph. Okay, we still have to account for the plus or minus, or the positive and negative values of those solutions as well. Even though they're imaginary, we have to account for them as well. And so that is what you're seeing on this last slide of notes. This is just kind of a side note. It's not a part of the rational root theorem, but it is a part of our learning target of understanding our roots in our solutions for higher power polynomials. Okay, so I would say definitely in your notes, when we are talking about imaginary solutions, we have to account for the positive and the negative values of those solutions. Cue this statement in this box. Okay, so pause the video and I'll give you a second to write that down so that you've got it in your notes, and then we'll actually talk about what it means. And so one of the things that we mentioned earlier in this course was imaginary solutions and how they are written using the letter I, and it's usually kind of an italicized letter I, which is what you'll see in that box that's got a star by it. And that just means this is an imaginary solution. It's not, 3i is not 3. It is an imaginary value that you can't physically put on a graph. Okay? The key word here that's probably throwing you for a loop is the word conjugate. I don't want you to freak out about that. Something that you could write there is change sign. Like draw an arrow beside that or off to the side in your notes. And conjugate, just think about it as changing the sign. Because a conjugate means whatever the solution is given to you, you also need to account for its counterpart. So if I gave you positive 3i, then its conjugate would be negative 3i. So it's this advanced looking vocabulary word that really just means make sure that you've got the positive and negative version of that solution. Okay? And where this starts to get a little tricky is when you've got a number plus imaginary. So if I've got something like 1 plus 3i, then its conjugate, which also counts as a solution, would be 1 minus 3i. Okay? And where are you going to get things like that? Well, you could definitely get an imaginary solution using the quadratic formula. Quadratic formula, take the square root of a negative number, and that's imaginary. So you may end up with something like this as you are using your quadratic formula to find some of these solutions. This could potentially show up if I just gave it to you, already worked out. For example, you'll see right here at the bottom in red, find a fourth degree polynomial function with real coefficients that has -1, -1, and 3i as its zeros. And I've already got it worked out there for you, but I just want to walk through that with you as well. The directions say find a fourth degree polynomial. So what's the largest power that this polynomial should have? It should have a 4. Which also means how many solutions should this polynomial have? It should have 4. Okay? That's all stuff that we learned last class. That's stuff that we've also already talked about in this course. So that's just a review. We're taking what we already know and we're applying it based on the directions. Okay? So just based on those first 4 or 5 words, find a fourth degree polynomial function. We know at the end of this problem that we should have 4 solutions and the highest power should be a 4th power. Okay? Moving on with the directions, find a fourth degree polynomial function. We've already done this. So find me a function with real coefficients and it has these zeros. So it has zeros of -1, -1, and 3i. Well, remember, zeros are the same thing as solutions or x-intercepts. So x equals -1, x equals the second -1, and x equals 3i. That's what the directions are telling us. When they give us those solutions, those are x equals. But here's the problem. It's a fourth degree polynomial. How many solutions were you given? You were only given 3. But you know that there's supposed to be 4. Whether they're real or imaginary, there's going to be 4 total solutions. This is what that box up top says. If you have an imaginary solution that is given to you, then its conjugate is also a solution automatically. So -3i, my directions are up there. Oh, no, I messed that up. My bad. 3i, I was right the first time. 3i is given to us as a 0 or as a solution. But automatically, because it is an imaginary solution, its conjugate is also a solution. What is the conjugate of positive 3i? We'll change its sign. Change it to negative 3i. Now you have 1, 2, 3, 4 solutions, which will give you a fourth degree polynomial. And so the last thing that we need, the direction said write a function, so f of x equals, and I need to rewrite a function using those 4 solutions. Well, I didn't tell you the structure of how the function had to be written, so don't create more work for yourself. If x equals -1, bring the -1 to the left-hand side, but aka add it to the other side, and rewrite this as x plus 1. Rewrite it as a factor. Okay, so you're like working backwards. You've already seen this in class, so this should not be something new, especially if you've been following along in our notes. Okay, but rewrite x equals -1 as x plus 1. Same thing with that next one. Move that over to the other side and get a factor group. Okay. Same thing with the third solution. X equals 3i. Move that over with x to get a factor. So this would become x minus 3i. And then the last one, move negative 3i. Add it to both sides. And so that last factor piece would be x plus 3i. That's got 4 solutions, obviously, because it's got 4 factor pieces. And the highest power that you're going to get is a 4th power. And so I found and I wrote a 4th degree function, okay, and I included all of its solutions. Okay, and that is what I would be asking you for. You're going to find that on your test. You're going to find several questions like that on your test. I think that there's one of the easiest things that we've done all year if you know the rule up above on in your notes about the conjugate pairs. Okay? And the reality is your calculator will not help you because you do not know how to graph imaginary solutions. Okay? So this is something that you have to learn. You can't figure it out from your calculator. You've got to know this content. Okay? And so the last thing that we'll take a look at for today is just practicing writing those polynomial functions, whether you are given real zeros or rational zeros, or if you are given imaginary zeros, or a combination of them all. Okay? And so I'm not going to do all of these because I think that you should be able to handle them. I'm going to do part B and part D. I'll give you the answers to part A and C at the end, and you can check your answers. You should be doing those just for practice, but I'm going to walk through part B and part D specifically. All right, so for part B, I want to write a polynomial function using the given information. So for part B, I need a 3rd degree polynomial. So I need a 3rd degree polynomial, aka the highest power is 3, the number of total solutions is 3. Okay? And I am given that this polynomial function has zeros or solutions at 3, -5, and -1/2. And so I'm going to write them exactly how I know that terminology to mean. Zeros of this and this and this, that means that they are x-intercepts or solutions. That means that I'm going to say x equals 3, x equals -5, and x equals -1/2. Okay. How many total solutions did they give me? They gave me 3. How many am I supposed to have? I'm supposed to have 3 because it's a 3rd power polynomial. Okay? And so this one's actually really fast. It's really easy. I need a function, and that function is a 3rd degree polynomial, so it's cubic. and I can write it in factored form. So instead of x equals 3, I'm going to write it as x minus 3. Instead of x equals negative 5, I'm going to rewrite it as a factor as x plus 5. And then even this last one, I know it's a fraction, but it is okay. Instead of x equals negative 1/2, I'm going to move that 1/2 to the other side and get a factor of x plus 1/2. Now there are some professors out there that would say, no, I don't want that as a 1/2. You need to rewrite that as 2x plus 1. I don't care. This is totally fine with me because it is written, it is in function notation, so you've given me a function and you have given me all the solutions that I asked for. Okay? And so that's it. That would be your answer. Now, that question only asked you about real solutions. So 3, negative 5, negative 1/2, those are all rational solutions. None of those are imaginary. But the point that I want you to see is that you treat them the same. The only catch is if you have an imaginary solution, you've got to account for its counterpart or its conjugate. Okay? And so that is also why I want to do part D. Okay? And so here's part D. I need a 4th degree polynomial. So before I go any further, 4th degree means my highest power will be a 4, and that means I better have 4 total solutions at the end of this. Okay? And the ones that they gave me are 2, negative 3, and 1 minus 2i. So x equals 2, x equals negative 3, and x equals 1 minus 2i. I've got 1, 2, 3 solutions. How many am I supposed to have? I'm supposed to have 4. Well, one of those solutions is an imaginary solution, so I've got to account for its conjugate. Do not complicate that. If I've got x equals 1 minus 2i, then I also have a solution at x equals 1 plus 2i. There are my 4 total solutions. And so all that's left for me to do now is to write my function. F of x equals, and I'm going to do the same thing that I've done on all the other ones. I'm going to shift the solution to the left side and rewrite it as a factor. So x minus 2 is a factor times x plus 3. And even though those back two look really complicated, don't change what you're doing. Move those to the other side. So subtract 1 on both sides and add 2i to both sides. And so this factor group would be x minus 1 plus 2i. And then my back one would be x minus 1, because I'm going to subtract the 1 away. But I'm also going to subtract the 2i to get it on the left-hand side. So my 4th factor would be x minus 1 minus 2i. Notice how their signs are opposites of each other here. That's the conjugate kicking in. Okay. There is my 4th power, my 4th degree polynomial function with those solutions. Go ahead and pause the video and try out part A and part C, and then you can resume and get those answers from the screen from me. Alright, check your answers for part A and part C. Let me know if you have any questions. That is all I've got for you for today's class. Next class, we will be taking all of those possible rational roots, those possible solutions, that list, and we will be testing them to see which ones are the actual answers that we are looking for. Okay. Keep in mind that Thursday is our last lesson of content. After that, it will be a review and then our test for Chapter 3. So keep that in mind. One thing that I do want to bring to your attention, and I'll send it out in an email as well, due to our class now being completely online, I am choosing to not continue to finish the graphing project. So I should have everyone's. I am finishing up grading those, and we'll finalize those on Wolfden here shortly. But we will not be pursuing or finishing that. So I will need to send that out in an email to you, but I will also adapt your schedule, that link to that Google schedule. I will take that out so that no one is thinking that that is due anymore, because we're not going to finish that up just because I've got the hard copies and you don't. Other than that, let me know if you have any questions via email or remind. On Thursday, I will share with you a potential game plan of how we will do our test review, to where we can meet face-to-face and actually talk and discuss any questions you have. I will give you more of those details on Thursday. Please bring a calculator, bring plenty of paper to write on for Thursday, because you're going to want lots of space, because what we are doing is going to take some space in your notes. But other than that, I hope you have a good one. Again, let me know if you have any questions. Email me or send me a remind if you've got anything that you need to discuss. Stay safe, wash your hands, and stay at home. That is all. Goodbye.